Hey, so let's continue on the theory of evolution, and we covered that evolution only impacts population, not species, not individual organism. Species and organism do not adapt, do not evolve. Populations do, right? Because evolution is the change of value frequencies in the population, right? So now that we've covered that, I want to start diving a little bit deeper in terms of the different types of evolution that are possible. So for evolution in general is one concept. Now you have evolution by natural selection. You have evolution by sexual selection. You have evolution by group selection. And you have multi-level selection. You have like many others, like social selection. You have other stuff right in there. So this is just one aspect of evolution. But we'll talk about two. We'll talk about natural selection and sexual selection. But I just want to put out there the fact that many others exist, right? So when you focus solely on natural selection and and sexual selection, you're not ignoring others, but you are refining evolution. So since evolution as a whole is just the change in allele frequencies, based on different conditions, you do get different outcomes. So one of the condition for those two here, you have actually three things that if three conditions, if they are met, thus you have evolution by natural selection and sexual selection. The other one rely on similar principle, but it gets a little bit more fuzzier. It gets fuzzier, so I would encourage you to go to graduate school or continue your exploration of biology if you want to learn more about the subtleties of all those. But the three conditions, once met, so let's write it that way. Three conditions. The first one is variability of the trait. The second one is heritability, and I will cover what those things mean. And then the last one is differential reproductive success. And due to the trait, I like to add those. And when those are met, we have evolution by natural selection. We'll just go with natural selection, right? I wonder if I can underline. Yep. Yeah, we'll keep that. Sweet. So those are the conditions. Variability of a trait means that not all individuals are the same. So you have some individuals that are red, some individuals that are green, some individuals that are different colors, right? That is the basis for evolution. If we can select based on variation, right, that is good. If we don't have variation, everybody has two limbs and two legs and two arms, well, you're not going to really get changes there. For changes of a body plan, it takes way more than that. Okay, now we have heritability of a trait. So we have variation. People have different hair color. People have different eye color. Now heritability means that offspring tends to look like their parents. So you follow the law of inheritance, and you remember BIO112, and you realize, oh yeah, offspring share parental traits. Sometimes combination of parental traits make different offspring types. But most of the times, if your parents are a certain way, you tend to look like them. And I insist on the tend. It's not 100% one-to-one thing, right? Which is important. It creates variability, right? Once you have those two, you need a third condition, because if there is none of the third condition, you then find yourself, kind of a moot point at this point, because you need differential reproductive success. If all individuals make the same number of babies, it doesn't matter that they are different traits. They all lead to the same output, same number of babies. Why is the number of babies? What is the number of babies essential? of offspring, it's because that's the number of copies of the genes, of the number of alleles that are put out there. So we assume that with the variation of a trait, different individuals have different traits. Those traits are heritable, so the offspring tend to look like their parents, and those traits lead to differential reproductive success. Some individuals with some traits have more success. Think about the giraffe example. Giraffes with longer necks tend to have more success, more babies, because they have access to more resources, right? And boom, if that happens, there is change in allele frequencies. That is called by natural selection, and that's because of the struggle for existence, the differential reproductive success. So in your PowerPoint, you have these here. And those are basically the same thing. It's the same thing as what I just talked about. Genetic variation, variability of a trait, heritability, limited resources, overproduction of offspring, struggle for existence, unequal reproductive success. All of that is the differential reproductive success. So you have three conditions, basically. You need overproduction of offspring, because if you don't have more offspring that the environment can carry, it means that those offsprings will have plenty of resources. There will not be a struggle for existence. If there is no struggle for existence, everybody gets to make it, and thus you don't have selection by natural selection. You don't have evolution by natural selection. That's what natural selection is. So when we apply this to a concrete example, so let's take a look at that seahorse, and you have that in your manual. When you take a look at that seahorse here, you have to ask, how did we get there? How do we have a seahorse that looks like the coral? If we assume that the seahorse looks like the coral to look like the coral as a camouflage, we imply that that organism is somehow changing its appearance to look like a coral, when we know populations evolve. So we have to use a different way of thinking about this. And that's based on those three conditions. Imagine a population of seahorses, and we can start where it is here, with all the seahorses looking that way. They look kind of like the coral, but they don't all look the same. Some of them are more or less red, some of them are more or less little bumps here, and the coral has more or less little bumps as well, so some of them look better or more like the coral than others. Those traits of looking differently, assuming this is heritable, so it means the offspring of individuals that look more like the coral tend to look more like the coral, and the offspring of individuals that look less like the coral, like the coral, tend to look less like the coral. That's heritability. And now we have to have a third condition, which is differential reproductive success due to the trait. Or individuals looking more like the coral tend to be predated upon less by predators, so they tend to stay alive and make more babies. And we said tend, you know. It doesn't mean it's like everyone gets predated if they don't look perfectly like the coral, no? Right? It's just more predation for those who look less like the coral. So now we have only individuals looking extremely like the coral who make it. And due to that, we find ourselves with a population. If you look at the allele frequency in that population, you have a culling out of the alleles that lead to individuals not looking exactly like the coral, or not looking perfectly like the coral, and that culling out changes the allele frequency. So now you have evolution by natural selection, and the population tend to look like the coral. That's starting with individuals like that, but you can start with individuals that don't look like coral at all. All you need is a random mutation that leads to an individual that now looks slightly more like the coral. So you start from seahorses that are completely white, strikingly white on a red background of a coral. They're really visible. If any individual starts to have a blotch of white on it, he may confuse predators. It may be enough to get the individual to safety before being predated. It may not be, right? That individual may be eaten, may die because there is a malformation, like there are other issues. The individual gets struck by lightning, you know, all those random stuff. So do keep that in mind. It's not because you have a trait that leads to better differential reproductive success, that leads to better reproduction, or that leads to better survivability. That's not because of that means boom, it's going to get selected. Many times, individuals that were randomly having an awesome mutation that allowed them to do something awesome, they just died. Lightning. Flood. So evolution, that doesn't have really a direction. It's really the randomness of it all that leads to some individuals making it while others are struggling through. Really important to remembering that it's not a guarantee because there is an adaptation that arises that is perfect for the environment. It's not a guarantee this will spread. At low frequency, all traits are susceptible to chance events, and we'll detail that a little bit later. For now, in this video, I just wanted to emphasize the conditions, the 3 conditions: variability, heritability, differential predictive success, and explain a little bit with a seahorse example what I mean. In the next video, I will detail a little bit more about evolution subtleties and misunderstanding, and we'll dive a little bit deeper into all that. Okay, I'll see you in the next one. Take care.